Okay, the next step is to compute probabilities. We'll start with the marginal probability first. So remember the formula for naive Bayes. The formulas are you need the marginal probability and then the conditional probability of each predictor variable value. So we start with P of f and P of t in this example. Here it will be P of delayed. So we'll have P of delayed or P of on time. Those are the marginal probabilities. So this will be, okay, for each table you have the number of flights delayed and number of flights on time. So that's going to be the grand total is going to be the same for all of these tables because it's from the same data. So we can use any one of these tables. So let's use the first one, C17 divided by E17. And let's make E17 absolute referenced. So that will give us the marginal probability. Okay, now, since we have set up the formula with absolute reference, we can copy it to the next cell, and that will give us the on-time marginal probability. Okay, so now we need to compute conditional probabilities conditioned upon whether it is delayed or on time for each of the value of each predictor. Okay, so the first predictor is carrier and the values are starting from B9. Okay, so B9 through B16. So these are the distinct values for the predictor carrier. Now we want the conditional probability of each of those carriers given delayed or given on time. So which means given delayed means this column, given on time means this column. So here this will be, you want C9, right, divided by C17. Now if you absolute reference this properly, so you want the column to change for C7 from C17 to D17 when you copy it over. So no dollar for C, but when you copy this formula down, the grand total should always come from 17, row 17, so dollar for 17. So that will give you the probability of CO, carrier CO, given delay. So these are the conditional probabilities for the predictor carrier. We do the same thing here, B21. Okay, so we have 7 of those, day of the week, and once again, probability of the day of the week given. So the conditional probability for the 2 predictor values. So this can easily be extended. If you have 3 predictor values, then you will have delayed, on time, and maybe cancelled or something. The third one could be. Then you will have 3 columns here. That's the only difference. So now C21 divided by C28, and once again, no dollar sign for column. So, that's the conditional probabilities for the predictor day of the week. Now the departure time is C32 divided by C49. You have absolute reference this properly. Now let's copy that all the way through here. Okay, so now destination is B53. And probability is C53 divided by C56. Three of them. We have that. Now origin is B60 and C60 divided by C63. And finally weather is 0 or 1, so B67 C67 divided by C69. So now we have all the probabilities we need. We have the marginal probability and we have the conditional probabilities of all the predictor variables, and for each predictor variable we have these probabilities for each value of the predictor variable.